I'm Lynn Toman, and this is Three Takeaways. Today, I'm delighted to be with John Hennessy. John is one of the world's leading computer scientists. He received the Turing Award, often called the Nobel Prize of Computing. He also served as president of Stanford University, and today he is chairman of Alphabet, Google's parent company. Few people have had a front row seat to as many tech revolutions. John, it's great to be with you again. Welcome to Three Takeaways.
Thank you, Lynn. Delighted to be here.
It is my pleasure. Let's start with why this moment is different. You've had a front row seat to almost every major computing revolution of the last 50 years. Is artificial intelligence the biggest one?
I would say it is for one particular reason. It changes everything. The internet certainly changed the way we do a lot of things, the way we interact with people, the way we shop, the way we do things. But it didn't change some more fundamental things about how we operate. Same with the microprocessor or the personal computer. It changed various aspects. But artificial intelligence is going to change the way we do science, the way we interact with people, the way we get things done, the way we get customer service, for example. So I think because of its ability to replace function or augment human capability, that makes it unique.
Have you ever seen a technology improve this quickly?
No, it's a fascinating question. So about 10 or 15 years ago, we had a discussion among the Google board. And the question we put on the table was, which technology is going to be more influential, the internet or AI? And at the time, all the board members, except the two founders, Larry and Sergey, they said AI. Everybody else said the internet. We had the discussion about 2 or 3 years ago, and everyone had flipped and said no. And you see the rate of progress is phenomenal. I've never seen any technology move quite this fast.
If we were looking back 10 years from now, what would have to happen for people to say AI has truly changed the world?
We've already achieved sort of the first hurdle in what we think of as intelligent behavior, which is a long-standing test invented by Alan Turing called the Turing test. And what the Turing test says is that if you're carrying on a conversation across the internet, let's say, and you can't tell if you're talking to a computer or a person, then you've reached a level of intelligence. And that was Turing's original test. This is done. You cannot tell that you're talking to an LLM versus the real person right now. But they still don't have broad intelligence across a variety of fields. So if you look at, there's a great benchmark called Humanity's Last Exam. And it's a collection of 2,500 hard problems. Hard meaning they're college level seniors for people who are majoring in that field, for example, right? So they're doable problems, but they require a level of sophistication and education. Right now, the best systems in the world achieve about a 60% grade on that. They solve 60% of the problems. So in my book, as I remind everybody, as a long-term professor, 60% is a failing grade. So we still have a ways to go in terms of broad reasoning intelligence, the ability to reason, which is what humans can do really well. We still have a ways to go on this problem.
Everyone talks about artificial general intelligence as if it's a destination. But what is the actual bar? What would have to be demonstrably true for you to say we've crossed the line?
Yeah, it's a very good question because the first observation you make is everybody talks about doing it, but there is no widely accepted definition of what it means. Other than you can reason across a wide range of problems, you can compete, let's say, with people who would regard themselves as professionals or well-educated in a field. So we're getting there. But the thing to remember about the current state of the LLMs, a lot of what we see as intelligent, like answering questions. What is the capital of France? It's Paris. Well, how does it know the capital of France is Paris? Because it's read every single document on the internet. And it's read that thousands of times. And it's basically memorized that connection between the two. And it's parroting back that connection. So lots of intelligent behavior is memorization. And the real challenge is to get to reasoning, which really makes us different. And when we get systems that can really reason through complex problems, I think then we'll know it's AGI. I'll know it when I see it. That's for sure.
So suppose we do cross that line of reasoning to artificial general intelligence. What becomes possible that simply isn't possible today?
Well, I think we could automate a lot of functions that are very hard to do. And it'll get used in different ways in different parts of the world. I think if you look at developed countries like the US, it's quite likely that AI will be an augmentation of what people can do. So it'll be there to help a physician maybe sort through a diagnosis of a difficult case. It'll be there to help students and help a teacher who's struggling with students at various levels of capability in a classroom. It'll be there to support legal systems and help get better access to legal services. But it'll also do something very different in other parts of the world. And so much of the world in the global south, there's a shortage of medical capability. There's a shortage of teachers. There's a shortage of lots of things that require more sophisticated education. And this technology could really help them advance at a rate which currently they don't have the human capital to do it. So that could really be a real way to raise the standard of living and the domestic product around the world.
As chairman of Alphabet, the parent company of Google, you're in a very unique position. What's the single biggest idea about artificial intelligence that even well-informed people still don't fully understand?
I think probably the most important thing to understand is that these systems learn in a very different way than people learn. They learn by taking massive amounts of data. If we, for example, to have a child in school capable of reading and writing, we had to first show them thousands and thousands and thousands of documents before they were able to read or write. We would never get to that. Humans have an ability to do intelligent things that is quite remarkable. It's astonishing. A human brain consumes about 30 watts of power. A data center consumes thousands of watts of power. So there's an enormous difference in terms of our ability to do things efficiently. And if we ever want to achieve something that really comes close to human capability, we're going to have to get more inspiration from how the brain is organized and figure out what can we take advantage of to make something that's much more efficient than the current designs.
So you think that AI will have to get more efficient like human brains as opposed to having data centers in space?
And I mean, data centers in space are fine. There is a small problem with how you maintain them and a few other problems. I think people don't realize about data centers in space. One of the major design problems is how do you cool it? Space is largely a vacuum. Therefore, you can't cool it by conventional means. You have to basically have the equivalent of, as you have giant solar panels, you have to have
Mhm.
giant radiators that are radiating the heat out into space. So it's not as easy a problem as it might seem at first glance.
It certainly doesn't seem like an easy problem.
I suppose is the right answer. It's even harder than we thought.
There's a growing debate about whether AI will concentrate power in a handful of companies or democratize it by giving billions of people extraordinary new capabilities. Which future do you think we're moving toward?
I think you're going to see AI propagate down. It may be that some parts of the technology stack are dominated by a few players. That's been true in the technology business for quite some time, right? I mean, in the PC era, it was dominated by Microsoft and Intel, for example. So that's been true for a while. But the real power of AI comes from applying it in the context of some particular area or problem you're trying to solve. And that will happen in a much more democratized fashion with lots of people building pieces of that stack.
Many people assume that the biggest danger from AI is science fiction, a rogue super intelligence. From your vantage point, what's the real world risk that worries you the most?
The one that worries me probably the most is use of AI in weapon systems that would be autonomous. So there's no human in the loop anymore. You're not just identifying targets and various other things, which I can imagine an AI system would be useful to do, but you're actually letting the AI system decide to fire a missile or do something else. I think that could lead to a nightmarish scenario because humans would no longer be involved in war. You could make it in a way that could be extremely dangerous. We've already seen a bit of this in the drone battle that's going on in parts of Ukraine and Russia, for example, or in the Middle East. I think figuring out how we're going to prevent that, just as we did with, say, a poison gas and a ban on biological weapons, that has to be negotiated at a multi-level, global level.
That certainly is a nightmare scenario.
It is a
On the
nightmare.
It is. On the flip side, what's the opportunity that excites you the most?
I think one that particularly excites me as a lifelong academic and researcher is that we could get dramatically improved rates of scientific discovery to work on really important problems. Imagine unleashing this technology on finding a solution for climate change, for example, figuring out how to do nuclear fusion and really make it work so we'd have a carbon-free energy source, figuring out how to find solutions to Alzheimer's or Parkinson's, right? Neurodegenerative diseases. Those are things which really excite me because I think the positive impact on human existence could be enormous.
How should people use AI?
I'm a big believer that the primary focus of AI is augmenting human capability, not replacing it. So using it to polish a document that you're writing is a great idea. Using it to help you think through various ways of doing something or composing a communication. Using it to simply replace doing the human part of it, it's probably a good idea. You may not be happy with the results. So that's something you want to think about. How do you keep in the loop on anything you're creating? We say about people who are using AI in research is you're responsible for the results that get published, not the AI system. If there's something wrong in that scientific paper, don't.
So you're really talking about using AI to leverage humans, to leverage
Yes.
people.
Leverage augmentation, leverage capability. Yes.
AI tutors may soon become better than human teachers for many subjects. If that happens, what is a university actually for 20 years from now?
Yeah. I think there's some interesting research on exactly this area. And what it's demonstrated is that students working with AI tutors alone do well. The tutor improves the ability of the student to get their work done as opposed to a student working without a tutor. But the best combination is student, teacher, and tutor. And the tutor, then the AI tutor, can take guidance from the teacher as well as from the understanding from where the student's gap is and combine them. And I think we're going to see more of that model where people are not pulled out of the loop, but where the AI tutor is an assistant to either a human teacher or a human tutor for that matter.
And how will that change universities?
I think universities are going to have to change right now. I mean, we're already thinking about this. I mean, I'm an engineer, right? I'm a computer scientist by background. In computing and engineering and the sciences, the typical way of helping students learn material is with problem sets. So they do problem sets, right? They go to a lecture, then they get a set of problem sets and they learn how to do the problems. Then when it comes to the exam, they know how to do them and they do well on the exam if they did the problem sets. The temptation now to just go online and get the answer to the problem set has made it too easy. So we need to think about how do we change our education system? And I think the way it's going to change is more person-to-person contact, more of a model where students sit down in small groups with faculty member with a teaching assistant and really go to the whiteboard and work the problem out on the whiteboard as a way of teaching. It's not unlike the model that Cambridge and Oxford have used for more than 1,000 years, right? A tutorial model of education. And I think that is going to play a bigger role going forward.
You've thought a lot about leadership. Do you think the biggest constraint on human progress is going to be technology or leadership?
Oh, that's a good question. I think the biggest limitation on human thriving, I think, will be leadership. Because good leadership that ensures that all boats rise, that society as a whole thrives, requires leadership. Technology alone can't ensure that.
So the obvious follow-up is if AI starts outperforming humans on many cognitive tasks, how does that change what leadership means?
I think, the challenge in my experience, the hard thing about leadership is all the difficult problems are people problems. They're all people problems. And I don't see an AI system coming in and solving those difficult people problems. I think people are going to still want to be talking to a person. It's the same thing when I think about the future of medicine. I do believe I want an AI system there reading my x-rays, reading all my diagnostic tests, putting that all into a model and trying to get some insight. But if the doctor is going to tell me I have a serious illness, I want to talk to a physician, not to just the computer. So that's, I think, the way to think about it. And I think that's true in leadership too. People they want to work with other people and they want to do things as a team that they couldn't do alone.
Imagine a young person listening to this conversation who's excited and maybe a little anxious about AI. What would you tell them?
I'd say learn how to use AI as a tool that will enable you in whatever field or career you go into to be more effective. Because I think what's going to distinguish people in the future is whether or not they can use AI as an effective tool in the context of what they're doing.
You're really saying don't use it as a substitute for homework or work.
Right. You need that cognitive development, right? You need to do hard things. It was interesting. Sundar Pichai gave the commencement address at Stanford a few weeks ago. And what he said is, don't be afraid to do hard things. Tackle hard things, because those are the things that'll make a difference and will also develop your skills as a person.
That's wonderful. John, what are your three takeaways? What would you like the audience to remember about AI?
So first of all, AI is a tool. It's nothing more. There's no magic sauce here. It's a tool that's been trained on lots of data, so it realizes lots of things, but it's a tool. It's a tool for you to use. Second, it is not omniscient. It doesn't know everything. It knows a lot of things, but it doesn't necessarily know everything. And third, the most important uses of AI are ones that augment and enhance human capability, not simply replace humans.
John, this has been wonderful. Thank you so much.
Thank you, Lynn.